Hello dear students, welcome to this session. In this session we will discuss about refraction through prism, right? So let's start today's session. As we have studied the refraction through the glass plate, through the mirror and through the thick glass slab. So now we are switching refraction through the prism. Let's see what are the differences here when we are doing the refraction through a prism. Here you can see a beautiful prism is here where there is a refraction of light, as you can see, though it should be like this. We'll discuss about this. Let's see whether this refraction is correct or incorrect. We'll see in the next few slides. So first of all, what is prism and structure of prism? We will discuss about this. What is prism? So as you can see here, we'll write down the definition first of all. The prism is a solid as it is made of glass. Homogeneous. Why I am saying homogeneous? Because the refractive index of each section everywhere will be same. That is why it is homogeneous. The refractive index everywhere will be same on the prism. Okay. So prism is a solid, homogeneous, refracting surface, also transparent, and refracting surface inclined by two plane surfaces at a given angle known as prism angle, angle of prism. So this is what the definition of a prism. Now we will draw the prism according to this definition. So prism is a solid, means material is of glass, homogeneous, transparent and refracting surface, okay, inclined by two plane surfaces. Let's see here. We'll draw a prism. As you can see here. So there are the two surfaces which are inclined. This one and this one. These are the two inclined surfaces like this at certain angle. And what is the angle of these two inclined surfaces? One surface is this one, and another surface is this one. These are the two inclined surfaces and the angle of incidence is this. Right, this is angle of incidence. These are the two surfaces and the angle, prism angle is this angle. This is the prism angle. This is the angle of prism. Okay, are you getting? Again, these are the two surfaces. One is this, another is this. Okay, and the angle made between these two inclined surfaces is known as angle of prism A. Okay, this angle is known as angle of prism. and these two are refracting surfaces. These two are refracting surfaces, right? This is base. Okay. So total there are 5 surfaces. 1, 2, 3, 4, like this. This one is one in front. Suppose that A, B, C. So this one, 1, 2, 3, 4 and 5, right? This base is 5th, and this is the first. This one is the first, 2, 3, 4 and 5. So the total there are 5 surfaces. Two plane surfaces are inclined, which are refracting surfaces, and the angle between these two is known as angle of prism. Got it? So this is what the structure of a prism. Now we'll discuss about the refraction through the prism. Refraction through prism. So how the refraction takes place through a prism, try to understand. Let's see. We'll draw a prism here. Now we will take the 2D diagram only. Okay. The central part we are showing here of a prism. So this is angle of prism A. Suppose that PQR. This is a prism. Any light ray is incident on the refracting surface QP or PQ. Okay. Any light ray is incident on refracting surface PQ. So this is the light ray which is incident on this refracting surface. Okay. So from where it will go? To know that, we will draw a normal here. So this is the normal. Okay. Make it more bigger. Let's make it more bigger. Okay, so we draw a normal here. Now, as you know that here we are using air, here too air is there, and this is of glass, right? So when light ray will enter from air to glass, what will happen? It will move towards the normal. So it will bend towards the normal. Though it should go like this, it should go like this, but it will move towards the normal and will go like this, right? So this is what the angle between incident and normal is known as angle of incidence, and this the angle between refracted ray and normal is known as angle of refraction, suppose R1. Okay, got it? Now what will happen here? Again we are moving from glass to air, so refraction will occur. We'll draw a normal again on this surface. So this is the normal. Okay. Now as light is moving from denser medium to rarer medium, it should go like this. Though it should go like this, but not. It will move away from the normal. Earlier it was moving towards the normal, but now it will move away from the normal. So it will go like this. Okay. So this will be the angle of incidence. Suppose that now we are taking the angle of incidence R2, and this is again the angle of emergence E, or we can write down it I2. Right? Why I am writing I2 here? Because there will be the principle of reversibility. You have studied about the principle of reversibility? Means what? If this will be the incident ray, then it will follow the same path, and this one will be the incident of it. This one will be the refracted ray. Are you getting? This is angle of emergence right now. I wrote it I2. I2 means angle of incidence. Why I did this? Because if we are considering this as a incident ray, then this one will be the angle of incidence. And it will follow the principle of reversibility. Means the same path it will follow, and this one will be the angle of refraction, the same, which is I right now. That will be the angle of refraction following principle of reversibility. Okay. So this is angle I2 or angle of emergence, right? It's up to you whether you can write I2 or angle of emergence E, anyone. Okay. So as you can see here, now it is very visible to you that this was the path of the light initially. This was the initial path of the light, but it is going on this path. Means the light has deviated a lot from its path. Light should go like this, but finally light is going like this. Means there is a lot of deviation on the path of the light. How much this light has deviated? It should go like this, and moving like this means if we will extend this angle is the angle of deviation, and this much is light has deviated. Its path should be this, but is this now? It is this now. Okay. So this angle is known as angle of deviation. So how much will be this angle of deviation? This is what we are going to study now. So let's suppose if this angle is I, then this angle should be I, right? Let's see. If this angle is I, then this angle should be I. If this much is R1, then this one will be I minus R1. Are you getting? So this angle will be I minus or I1. Suppose that this is I1. So I1 minus R1. As I wrote here, this angle will be I1 minus R1. Again, if this angle is I2, then this angle should be I2. And if this part is R2, then this remaining part will be I2 minus R2. Okay, I2 minus R2. Now, suppose that this point is M. This point is M. So we are taking, let's give this point A. We have marked every point. Now, see, in this triangle, MAB, or in triangle AMB, right? This one, this triangle. We are talking about this triangle AMB. Okay. So this is angle which is exterior angle here, and these are two interior angles. So exterior angle is equal to exterior angle is equal to sum of interior angles. Right? So delta is equal to I1 minus R1 plus I2 minus R2, or we can write down I1 plus I2 minus R1 plus R2, right? This is what the value of delta. Equation 1. Now, if we will extend these two, we'll meet somewhere here. So this is a triangle ABO. In triangle ABO, the sum of these three will be 180 degree, right? the sum should be of these three angles should be 180 degrees. So how much this one will be? 180 minus R1 plus R2. So angle O is equal to 180 minus R1 plus R2. Have you got from where we got this? R1 plus R2 plus O. R1 plus R2 plus O should be equal to 180 degree. So angle O is equal to 180 minus R1 plus R2. Okay. Now let's see. Here is a as you can see here, this is a quadrilateral. Is it visible? This is a quadrilateral. Okay. Since it is a normal, so this angle will be 90 degree. Similarly, this is a normal, this is normal. So this angle will be 90 degree. Okay. We are drawing a normal on this surface, right? This. So how much this angle will be? 90 degree. This will be also 90 degree. So we took it 90 degree and this is 90 degree. We know that the sum of all these angles will be equal to 360 degree. As we know that A plus, suppose that Q in QAOB, quadrilateral, right? In this quadrilateral QAOB, the sum of Q plus A plus O plus B should be equal to 360 degree, right? It should be equal to 360 degree. Hence, let's see. This Q is equal to, put the value A plus A is equal to 90 degree plus O is equal to 180 minus R1 plus R2, right? Plus B is equal to again 90 degree is equal to 360 degree. Okay. So 90 plus 180 plus 90 is equal to 360 degree. Got it? So A plus A minus R1 plus R2 is equal to 360 minus 90 plus 180 plus 90, 360. So this will be cancel out. Okay. So what we will get? A is equal to R1 plus R2. From here we will get A is equal to R1 plus R2. We'll put this value here, R1 plus R2. We'll put this value R1 plus R2 is equal to A. So what finally we will get? Del is equal to, use this place. So finally we will get del or angle of deviation is equal to I1 plus I2 minus A. In place of R1 plus R2 I put A. So minus A, or what we can say, del plus A, we can write del plus A is equal to I1 plus I2, or del plus A is equal to I plus E. So these are the formula we can write down. Okay, so this is angle of deviation, del is equal to I1 plus I2 minus A. What is A here? Angle of prism. It can be 60 degree or any other end. Okay, so A is angle of prism, del is angle of deviation, I1 is angle of incidence, I2 is angle of emergence. Got it? So this is the formula which we derived here. Moving ahead, hope that it is very clear to you. Okay, once again, moving on next slide. So that's all for today's session. Would like to wind up this session with this beautiful quote which says that never be so busy as not to think of others, according to Mother Teresa. Means what? Sometimes in our life we are so busy that we forget everything. Suppose there is a situation you have to go to your school and principal is very strict. If you will not reach at the time, you must be scolded. In the way, you saw that there are any blind person who is trying to cross the road and he is getting it very difficult for him. It is very difficult for him to pass the road as traffic is very high and he is not able to cross the road. But if you will help him, probably you will be late in your school. So in this condition, this quote will be applied. Never be so busy. In what you are busy, that I have to reach on the time. This is what your busyness, because you don't have time. You don't have enough time. You have to reach on the school exact on the time and you are already late. So you are in hurry to reach the school on the time. So in that condition, you have to think about others. Let yourself late. Accept that punishment. But you have to help that person who is trying to cross the road. Right? So this is the message hidden in this quote. With this message, I would like to wind up this session over here. We'll meet in the next session. Till then, take care of yourself. Have a great time.